Hello, my name is McLaughlin, and this is a presentation created for Capstone 2021 on emulation as a service and technique in the field of digital preservation. This presentation is designed for those interested in emulation technology and its origins, as well as those in the field of digital preservation, both new and old. This presentation aims to give a broad view of the topic of emulation and its applications. What is emulation? Emulation is defined as hardware or software that permits programs written for one computer to be run on another computer. The goal of emulation is to provide an exact replication of the functionality of the system that is being emulated on a non-obsolete or current hardware. When considering digital preservation and the preservation of obsolete media, emulation is a technique that can be used to ensure software is still accessible to be studied, as well as to give researchers context about the original digital object. Emulation is primarily used to preserve obsolescent software or hardware and to replicate systems or software that are not readily available for both research and public use. Because emulation can provide access to a digital object in its native environment, maintain the look and feel, characteristics, and utility of the original item, it's a great tool for preserving both hardware and software. Jeffrey Rothenberg, an early proponent of emulation as a digital preservation strategy, stated that the best way to satisfy the criteria for a solution is to run the original software under emulation on future computers. This is the only reliable way to recreate a digital document's original functionality, look, and feel. Though it may not be feasible to preserve every conceivable attribute of a digital document in this way, it should be possible to recreate the document's behavior as accurately as desired, and to test this accuracy in advance. Rothenberg, 1999. There are four primary emulation softwares utilized by archives, most of them created by David S. H. Rosenthal. These softwares include QEMU, a free open source emulator and virtualizer that can perform hardware virtualization, MAME, a free open source emulator designed to recreate the hardware of an arcade system in software on modern personal computers and other platforms, Basilisk 2, an emulator which mimics Apple Macintosh computers based on Motorola 6800 series, and DOSBox, a free and open source emulator of an Intel 86 personal computer designed for the purpose of running software created for disk operating systems on IBM PC compatibles, primarily DOS video games. This is just a small selection of emulators available in the field. Emulators can also be created by hobbyists, special archives, and large companies or institutions. Now that we know what emulation can be defined as, what are the current advantages and disadvantages to emulation as a preservation tool? First, the advantages. One advantage of emulation is providing context. By its nature, emulation helps preserve the context of an item, which can vary by the user of the information. Utilizing emulation can also often provide access to the object in its native environment, maintaining the look and feel, characteristics, and utility. This is key to understanding how the original software looked and felt. As emulation is still a relatively new technology in the field, it doesn't yet have widespread adoption for a number of reasons. These include that there are a variety of technology and intellectual property issues associated with emulation, which includes the actual software application used to render the digital object, as well as the operating system and any dependencies. These intellectual property issues include copyright, license agreements, and digital rights management, or DRM. Software is typically covered by copyright. In order to make copies of the software for preservation and to provide access, the institution needs to be able to do so legally. Because software versions change and newer releases may not be backward compatible or offer the same functionality as previous releases, multiple versions of the software may need to be preserved. The emulator itself would also need to be preserved. Without extensive documentation about how the digital objects were created, there may be a need for a significant amount of testing of the object as well. Many parts of the original code, such as the BIOS, operating system, and software, can be and are copyrighted. This means that institutions need to go through significant legal research to acquire the rights to create emulations and emulators.
Although emulation can be an effective digital preservation strategy in some situations, it is not without its drawbacks. Emulators can be complicated to implement and may require extensive staffing. Computer programmers might be needed to create and maintain emulators. Digital preservationists and users may need to learn and understand the antiquated or unfamiliar computer systems that are being emulated in order to take full advantage of digital objects preserved through this strategy.
An important question asked when creating and utilizing an emulator is, what features are important to preserve and why? This question allows researchers to replicate the key features of a program or device to gain the closest possible experience to the original hardware, and to consider both computer and budgetary limitations. First, it's important to preserve and create metadata. Archivists need to create or restore multiple types of important metadata. These include technical metadata to enable migration, bibliographic metadata to assist users in finding preserved artifacts, usability metadata that defines things such as key bindings and computer settings, and usage metadata, which is also important for provisioning and justifying the archive's funding, as it depicts how often the emulator is being utilized. There are also two types of fidelity, or the degree of exactness with which something is copied or reproduced, to consider when creating an emulator. First, execution fidelity, or whether the emulation executes the program correctly, and experiential fidelity, or how close a user's experience is to the original user's experience. Luckily, recent developments in emulation frameworks make it possible to deliver emulations to readers via the web in ways that make them appear as normal components of web pages. This removes what was a major barrier to development of emulation as a preservation strategy. Preserving fidelity is an important function of making an emulator that is faithful to the original hardware. Though there are a variety of drawbacks and benefits to emulation, it should be considered as a viable option for libraries, archives, and museums to adopt, especially as a means of experiencing the hardware in a format that closely represents its original state. All of these advantages and drawbacks are meaningless without the institutions to implement these strategies. This refers back to Trevor Owen's 16 Axioms of Digital Preservation, which state, institutions make preservation possible. Each of us will die. Without care and management, the things that matter to us will persist for some period of time related to the durability of their media. The primary enablers of preservation for the long term are our institutions: libraries, archives, museums, families, religious organizations, and governments. As such, the possibility of preservation is enabled through the design and function of the institution. Their organization charts, their hiring practices, funding, credibility, and so forth are all key parts of the cultural machinery that makes preservation possible. Though not yet widely adopted, emulation is currently utilized by a variety of institutions to streamline their preservation process. The first example being the Olive Executable Archive. Olive is a collaborative project seeking to establish an ecosystem for long-term preservation of software, games, and other content. Olive was developed at Carnegie Mellon University and aims to address the current gap in preservation technology by providing a curated environment for the preservation and distribution of executable content. There are 5 main goals of Olive. They are to enable libraries to achieve their mission of preserving the scholarly record, provide a platform for preserving, searching, extending, and distributing executable content, establish a workflow for this preservation, determine the obstacles to preservation and distribution, retain the executable content in its original state such that the end users may interact with it freely. The Archives project, Olive, uses VMNetX, which runs on Linux and uses the open source KVM virtual machine monitor. VMNex can execute virtual machines directly from any web server. No special server software is required. Users are then able to access virtual machines in the collection, including Doom for DOS, MS-DOS 1993, Netscape Navigator, HyperCard, Oregon Trail, and Mystery House, which ran on an Apple II computer in 1982. Next is the Internet Archive, one of the largest emulator hosts available to date. The Internet Archive software collection provides instant access to millions of programs, CD-ROM images, documentation, and multimedia, making it the largest vintage and historical software library in the world. As part of this collection, they offer the ability to use software over the web, emulated in JS-MAME, which is part of the JS-MES package. This package emulates a variety of software, including but not limited to Atari game systems, Bandai WonderSwan, Commodore 64, Microsoft MSX, Nintendo game systems, Sega game systems, and Sony game systems. The JS-MES emulator is an ongoing project to port the well-established general machine emulator MES to JavaScript. The Salman Rushdie archives were acquired by Emory University Libraries in 2006. The archivists there wanted to approach the collection as holistically as possible and keep the original file formats when possible. This approach necessitated that their development of access points and tools embrace both the digital context and the larger context of the complete collection. Since Rushdie's computer was so old, patrons were not permitted to turn it on and search through it. Thus, the library needed to provide an emulated copy of the computer itself. In order to provide an emulation of Rushdie's earliest computer, a Mac Performa 5400, they used the Sheep Shaver emulator. The purpose of emulation for the collection was to assist in creating an authentic research experience. A copy of the final state of the laptop was made, and in a manuscript archives and rare book library reading room, a user can browse Rushdie's file on an Apple laptop, including his files, computer games he played, and other important interesting data. Though emulation has its positive and negatives, it is one of the more effective strategies to faithfully replicate the context of the original software. Emulation allows the next generation to experience these programs and find answers to the problem of obsolescence. As Trevor Owens states in his 16 Axioms of Digital Preservation is about making the best use of your resources to mitigate the most pressing preservation threats and risks. You are never done with digital preservation. It is not something that can be accomplished or finished. Digital preservation is a continual process of understanding the risks you face for losing content or losing the ability to render and interact with it, and making use of whatever resources you have to mitigate those risks. Digital preservation is a constantly evolving field, and emulation is one of many techniques that are at the forefront of this exciting new genre of archives. Thank you for attending this webinar on emulation and its uses in the field.